Hi, I am Wei Hao. Today I will be presenting my automatic counting circuit for the analog and digital electronic 2 course. In this video, I will showcase the schematic diagram, hardware prototype, circuit operation, and provide a demonstration to illustrate its functionality. Let us begin by examining the schematic diagram of my automatic counting circuit. This circuit incorporates an infrared sensor as the analog sensor to detect object and trigger the counting process. The sensor module includes an LM393 op-amp functioning as a comparator circuit. This circuit will generating the output pulse. When the sensor detects an object, it produces a high logic pulse, initiating counting in the CD4026B counter. Consequently, the 7-segment display accurately presents the digit according to the output decoder of the CD4026B counter. To offer user flexibility, a reset push button as shown here is included in the circuit, enabling the reset of the counting process at any point rather than waiting for a complete counting cycle. Next, let us look into the hardware prototype of this automatic counting circuit. Here is an overview of the hardware prototype and the component utilized. Now let us explore the prototype in more details. This is the hardware prototype, and let us turn power up it. One notable distinction between the hardware and software simulation is that the hardware infrared sensor module, as shown as here, generates a low logic signal upon the object detection. Since the CD4026B decade counter requires a high clock pulse to initiate counting, a SN74 LS04N hex inverter is employed to invert the sensor output signal before connecting it to the clock input of the first decade counter. This is the hex inverter as shown as here. Moreover, two CD4026 decade counter as shown as here, that is two CD4026B decade counter, are cascaded to enable counting from 0 to 99. The carry out pins of the first decade counter is connected to the clock pin of the second decade counter. This pin generates a pulse upon completion of one cycle, resulting in the second CD4026B decade counter incrementing the count by once only when the first counter completes a full cycle. Now it is time to showcase the circuit operation. By placing this white box on top of the infrared sensor, we can initiate the counting process as shown here. And the digit will be displayed on the 7-segment display. As we observe, the circuit presents two digits without any error even when the count exceeds 9. Moreover, I will demonstrate the functionality of the reset button now. At present, the count is at 20, and upon pressing the reset button, the count will reset to 0 as shown as here. Now the count is go back to 0. Lastly, let us examine the logic waveform of the 7 output decoder from the CD4026B counter when the infrared sensor detects object. As shown in the oscilloscope at the left hand side, the first waveform corresponds to the clock pinout of the first decade counter, followed by the 7 output decoder from the CD4026B counter, which is out A, out B, out C, out D, out E, out F, out G. This shows the push button is pressed. In conclusion, throughout this demonstration, it is evident that this automatic counting circuit successfully achieved its objective. Thank you for your watching.